Hello and welcome to Crazy Math Productions. We'll continue our unit on solving linear systems. We're going to do today, last time we had done solving by graphing. This time we're going to look at some algebraic systems for solving. Now, the first one we're going to do is substitution. There are two different ones that we can utilize. One is substitution, the other one is combination. So today we're going to look purely algebraically. Now, first thing to do is just to look at, well, what does it mean to substitute? Well, you may have had a teacher that's a substitute teacher. Basically, you're having someone to step in the place of, to be that for just one day. So we're going to substitute 2x plus 1 instead of y in each equation, solve for x, just as an introduction. So we see that this is y. Instead of putting y, we're going to put this, 2x plus 1. So negative 3x plus, I'm not going to put y, I'm going to put a big parentheses. So in the place of y, we're going to put 2x plus 1. Now I'm going to continue and solve for x. Now, these parentheses are not necessary anymore. There's nothing out front to distribute. So we have negative 3x plus 2x plus 1 equals 4. And let's continue to solve. Those of you who follow Crazy Math Productions know we like to sing a little song for this. First distribute, nope. Then combine all of your like terms. So negative 3 plus 2 is negative 1x. First distribute, then combine all of your like terms. Please remember key change, or you'll get burned, which we've done. Then get all your variables onto the same side, which they are. First addition or subtraction. Then multiply, divide. And multiplication, so we'll divide. And there we go. So that's the idea. Again, we'll do it here as well. Substitute it for y, so look for y. And we're going to put 2x plus 1 in its place. So don't put y, put a big parentheses. And write everything else as normal. Now put the 2x plus 1 instead of the y. Now we solve. First distribute. It would be helpful if I were actually distributing. First distribute. Then combine all of your like terms. 4x and x are like terms, so 4 minus 1 is 3x. Please remember key change, or you will get burned. More specifically for situations like this, if you had subtraction in front, you would need to make sure you distributed the negative. Then get all your variables onto the same side, which we have done. First addition or subtraction. Then multiply, divide. And there we have it. So that gives you just a little bit of a taste of what we're going to be doing. Now the process, pretty simple. Solve one of the equations for its variable, substitute that for the other, and then just simply solve. Now I'm going to do a variation of this that my students in the past have liked. So my process is going to be this. We're just going to simply pick a variable. So you know what, y is already by itself. I'm just going to say we're going to solve for y. Now, again, I don't have to do that, but just as a little note to myself, that's what I'm going to do. So to keep this extremely simple, what I'm going to do is to solve for y in both of the equations, and then just kind of go from there. Now, y equals x minus 3. I'll tell you what, as I had done in the previous video, let's identify these by color. So I'm going to use the top one as red and the bottom one as blue. So y equals x minus 3. Oops. Y is already by itself. Here, let's subtract 4x from both sides. Y equals negative 4x plus 32. And now the process is pretty simple. What we're going to do is, since we have solved for y on both sides. Y is x minus 3, and y is also negative 4x plus 32. So what we can do is sort of combine them together. X minus 3 equals negative 4x plus 32. And now we just solve for x. Let's see. First distribute. Nope. Then combine all of your like terms. Nope. Please remember key change or you'll get burned, which is completely optional. Then get all your variables onto the same side. First addition or subtraction. Then multiply, divide. Okay, now remember we have two variables, so finding x, well, it's helpful, but it only gives me half of the ordered pair. So now I'm going to have to go back through and find the other half. So x is 7, plug back in. It doesn't matter which one we plug in for. Let's say red. So y equals, plug the 7 back in, 7 minus 3, y equals 4. Now again, should it matter which one I plug it into? Well, no, it shouldn't, because if you think back to graphically, that one point that is in common with both of them, it should be true for both, so it shouldn't matter which one, red or blue, that I plug into. So there's my order pair, 7, 4. Okay, so again, I'm going to identify one as red and one as blue. And in this case, you know what, it really doesn't matter which one I solve for. You could solve for x, you could solve for y. In this case, do you notice how the x is already by itself? Well, that's going to save me a lot of time, so I'm just going to leave x by itself. And in the blue, since I've already solved for x, I'm going to solve for x in the blue one too. So I'm just going to say that I'm going to solve for the same thing. Notice up here, to remind myself, I said I'm going to solve for y. Here I'm going to solve for x. Just as a note to myself, it doesn't really matter. And so now I'm going to solve in the blue one for x. So we'll subtract 2y from both sides. Negative 3x equals negative 2y. And divide by negative 3. Negative divided by negative is a positive, so this is 2/3 y. Now, what's happened here is that I have x by itself, so what I'm going to do is to simply push these two together. Instead of putting the x, I'm going to put a 2/3 y, so 2/3 y instead of the x, and then bring down the rest here. So where the x's are, you just simply put just one on one side and one on the other side. Makes it very simple. Now we need to actually solve this. Now, I don't like this fraction here, so what I'm going to do is to multiply everything by 3. It's going to make it very easy to get rid of the fraction there. So 3 divided by 3 is 1, times 2 is 2. 3 times negative 5 is negative 15, y. And then plus 3 times 17 is 51. So now we do the song. First distribute, nope. Then combine all of your like terms. Well, no, we can't do that because on this side they are not like terms. Please remember key change or you'll get burned. Then get all your variables onto the same side. So we're going to add 15y to both sides. First addition or subtraction, nope. Then multiply, divide. And so now we're going to say that half of our solution set we have found. Y is 3. Now always remember X goes first, then Y. It's in alphabetical order. And now we have to figure out what exactly goes in the X slot. Now the red one is ready to go, so let's just use the red. X equals -5 times, well, what is Y? We think it is 3. And so now we're going to finish it off. -5 times 3, -15, plus 17, X equals 2. And there's my solution. Now, what exactly does the solution do? Well, you'll notice, and I'll let you do this on your own, if you were to plug in 2 for X and 3 for Y in each of these equations, you will get a true statement. That means that the order pair 2, 3 is a solution to both equations. Okay, now in number 3, it's not going to be quite so easy. The reason being that they haven't really told you what you're supposed to solve for. Now, it doesn't matter. You can solve for X or you can solve for Y. In fact, let me prove it to you. First, let's solve for X. And let's see if that works. Then we'll go back and solve for Y. And let's see if everything works out the same. Okay, first things first, let's do solve for X first. We'll do that at a later time. Solve for X. X minus Y equals 2, so we're going to add Y to both sides. So X equals Y plus 2. And now we're going to, since we've got an X by itself, that's good, we're going to solve on the blue one as well. So 2x plus y equals 1. We're going to subtract 2x from both sides. And I just realized that I solved for y instead of x. So let's go back and solve for x instead. So let's subtract y from both sides. Divide by 2. Let's, with this fraction, let's put it as a -1/2 y plus 1/2. And so we have x by itself. X by itself, x by itself, and each of the two. This is good. Okay, so now let's go ahead and put the red on one side, put the blue on the other side. And we need to solve this. Again, I don't like these fractions, so what I'm going to do is to multiply everything by 2. 2 times y is 2y. 2 times 2 is 4. Two divided by 2 is 1, times -1 is -1. 2 divided by 2 is 1, times 1 is 1 again. And so now I can actually go through and solve. So first distribute, nope. Then combine all of your like terms, nope. That'd have to be on the left side or the right side, but not on both at the same time. Please remember key change or you get burned. Then get all your variables onto the same side. Let's add the opposite. 2y plus 1y is 3y. Then get all your variables onto the same side. First addition or subtraction. Then multiply, divide. So y equals -1. So my solution set here, we have x we don't know, y is -1. Let's just use the red here. That seems to be convenient. You could use the red or the blue. It just looks like it's going to be easier to use the red here. So we're going to go ahead and plug in -1 for y. X equals -1 plus 2. X equals, well, that's just 1. So my solution set is 1, -1. Now, I had told you earlier, we should be able to solve for y as well. We've solved for x. It's worked out. Let's see if we could solve for y and get the same thing. Let's do the same process. Okay, this time let's solve for y. When we solved for x, we got +1, -1. Let's see what happens when we solve for y. On the red, I'm simply going to add y to both sides. And then subtract 2. So y is by itself. And now I'm going to solve for y in the blue. Let's subtract 2x from both sides. And y equals -2x plus 1. Okay, so y we've solved for on each side. So what we're going to do is we're going to combine the two together. Put the x minus 2 on one side. Put the -2x plus 1 on the other side. And we're simply going to solve this. First distribute. Nope. Then combine all of your like terms. Nope, again. Please remember key change, which is optional, or you will get burned. Then get all your variables onto the same side. So let's add the opposite of 2x. Then get all your variables onto the same side. First addition or subtraction. So we're going to add the opposite. Then multiply, divide. So get that x is 1. Well, that's pretty good. That means that our x coordinate seems to have been the same. Let's plug it in. Say again the red one. Red looks pretty easy to work with. Plug in 1 for x in the red. 1 minus 2 is -1. And so you see, by doing it two different ways, we've confirmed that yes, you get the same result, the same solution set, and that's good. So the basic process, just pick, solve for x, solve for y, it doesn't matter which one. Once you get them by themselves, set one part on one side, the other part on the other side, and solve. Plug it back in to get the full solution point. Okay, on this one. What I'm going to do is this time I'm going to think critically. I'm going to look at this and see, you know what, if there's something in front of the x here, you know, that means that I'm going to have to divide by 7, and these don't look easily divisible by 7 in the top one. Let's look at the 3. To solve for y, I would have to divide everything by 3, and these don't look easily divisible by 3. Now, if I need to, I could, you know, divide by 7, divide by 3. It's just I'm going to get fractions, and that's not going to be fantastic. But I could still do it. Now, let's look. Here I divide by 2. You know what? That looks better than these. Here I divide by 1. Well, that looks the best of all. So solving for y seems to be the best strategy I could come up with. So what I'm going to do is I'm going to go ahead and say, you know what? After looking at these and seeing which one is the easiest to solve, I'm just going to arbitrarily say, I'm going to solve for y. So let's solve for y. So let's go ahead and declare. Let's make this the red. Let's make this the blue. And I'm going to solve for y in each one of these. Okay, so solve for y, 7x plus 3y equals 43. Let's get y by itself. We can subtract 7x. Divide through by 3. Y equals negative 7/3 x plus 43/3. I'm just going to leave these as improper fractions. Let's look at the blue. It would be helpful if I could copy down correctly. All right, so we're going to solve for y here as well. Now, I'm just going to, since I've got this minus 1y, I'm just going to add y to both sides. I just think it's a little easier to work with. And then add the opposite of this 10 to get rid of it. So y equals 2x plus 10. So I have y by itself here as well. Now let's combine them. Put this on one side. Put this on the other side. And I need to solve for x. Okay, now the first thing I would like to do is to get rid of the fractions. Since we have an equation, we're allowed to do that. Let's multiply everything by 3, which is the least common denominator of these two. Of course, in this case, it's the same. 3 divided by 3 is 1, times negative 7 is negative 7. Of course, don't forget the x. 3 divided by 3 is 1, times 43 is 43. Now you notice, if I'd have made these two fractions, rational numbers, into mixed numbers, then it would have been more difficult to get rid of the fractions. That's why I left them as improper fractions. And that can be the general rule. When you're going to try to solve for that particular variable, you know later on you may have a chance to clear it, so just leave it as an improper fraction. Not done yet. 3 times 2x is 6x. 3 times 10 is 30. And so now we're going to solve for x and use this on. First distribute. Nope. Then combine all of your like terms. No, that would have to be on the left side or the right side. Please remember key change, or you will get burned. Nope. Then get all your variables onto the same side. Well, we can do that. At the opposite of 6x, which is negative 6x. Then get all your variables onto the same side, first addition or subtraction. Then multiply, divide. So x equals 1. So the left-hand side, we have the x-coordinate is 1. Now we need to plug it in. Now if you look at the red, that's going to be a little difficult to work with in the red. It doesn't matter which one we plug into. So this time I'm going to choose blue, because if I plug in x for blue, this looks a little easier to deal with. So 2 onto 1 plus 10 equals y. 2 times 1 is 2, plus 10 is 12. And there's my solution. Okay, number 5. Now, if you notice, again, doing the same exercise, look at the x. That's going to be easy to solve for. But then again, so is the y. X here is easy to solve for, and so is the y. So really, it doesn't matter. I will just say solve for x, just because I chose it. You could solve for y and do very well. Okay, let's solve for x here in the red equation. Alrighty, so x plus y equals 8. To solve for x, we have to subtract y from both sides. X equals the opposite of y plus 8. X is by itself. And in the blue equation, x plus y equals negative 1. Subtract y from both sides. x equals the opposite of y minus 1, x is by itself. So this is good. Now we're just going to set them equal to each other. The opposite of y plus 8 equals the opposite of y minus 1. Now, first distribute. Nope. Then combine all of your like terms. Again, cannot do. Please remember key change, or you will get burned. Well, that's optional, but we could do it. Then get all your variables onto the same side. So I'm going to add the opposite to both sides. And very interesting, we end up with 8 equals negative 1. Well, what's happened is this. This is a false statement. If you were to go back and put these in slope-intercept form, you're going to find that in the red equation you have y equals the opposite of x plus 8. The blue equation, you would have y equals the opposite of x minus 1. Now you'll notice that the slope, think graphically from the lesson yesterday, the slope, negative 1, is the same, but the y-intercepts are different. What that means is that these are parallel lines. And if you remember parallel lines, what's the solution to a set of parallel lines? Well, there is no solution. And since we deal with a real number system, I'm going to say there's no real solution. These are a set of parallel lines. There is no real solution. All right, number 6. Let's try that. Again, I'm going to call the top one the red equation and the bottom one the blue equation. Okay, now let's look at this and see which one's going to be easier to solve for, x or y. Now, I have to divide by 6 all the way across. Those are not easily divisible. Divide by 3, that's easily divisible. This one's not. So y seems to be a little easier than x at this point, but not by much. If I divide by 4, well, that's definitely not easily divisible. But 2 really isn't either. So I'm going to solve for y because I think it's a little easier in the top equation to work with it, but it's really a toss-up. So I'm going to say solve for y, but they're both going to be pretty difficult to solve for. In my red equation, 6x minus 3y equals 4. Subtract 6x from both sides. Negative 3y equals negative 6x plus 4. Divide through by negative 3. And we have y equals negative 6 divided by negative 3 is positive 2 plus negative 4/3. In the blue, you know what? I just don't like dealing with the blue as it is. Since it's an equation, I am allowed to multiply through by the common denominator. So I'm going to do that even before I start solving for y. So we have negative 12x plus 6y equals negative 8. And this is just going to be much easier to work with. Okay, let's solve for y again. So we're going to add 12x to both sides. And divide by 6. Y equals 2x minus 4/3. If you notice, these are exactly the same line. Think back graphically. On number 5, we had a set of parallel lines. What happened when we had literally the same line? Well, there were solutions everywhere. Solution here, solution there, solution there, solution there. There's an infinite number of these. So what we're going to say is there's an infinitely many solutions. Now, once you see that these are exactly the same line, now be very careful. If there's any slight difference at all, then you may have to be careful and do a little more investigation. Of course, minus 4/3 versus plus negative 4/3. That's irrelevant. But you can notice in these that they're exactly the same line. If you can recognize that, then you can just go ahead and say there's infinitely many solutions. In this one, if they have the same slope but a different y-intercept, if you've got them in slope-intercept form, you could also do the same thing. Now, the other thing is, if you've done more investigation with number 6, what's going to happen is you're eventually going to get a true statement. Let's go ahead and join these together, and I'll show you what I mean. 2x minus 4/3 equals 2x minus 4/3. Now, get the variables onto the same side, subtract 2x from both sides, and we get negative 4/3 equals negative 4/3. So there's really two scenarios. If you have no variables and it's a false statement, really it's a set of parallel lines, so there's no real solution. It will always be false, is what the equation is telling you. Whereas on number 6, you have no variables but a true statement. So it's telling you it doesn't matter. It's always going to be true. So there's an infinite number of solutions. Let's do some word problems and get a little bit of context on these. The perimeter of a rectangle, is 30 centimeters. Find the area of the rectangle if the length is 3 centimeters less than the width. Well, with my students, I like to do a 5-step process. Let's say let, write, solve, check, and sentence. So we're going to do that 5-step process for both of these. Now the perimeter of a rectangle is 30 centimeters. Well, that's interesting. The perimeter is going to be based on two things. It's going to be based on the length and the width. So I'm going to go ahead and define those things. I'm going to let. I'm trying to see if I can use a thinner marker here. Let, say L equal the length. Also, we need to let W equal the width. Now, they say the perimeter is 30 centimeters. Well, we know something about the perimeter of a rectangle. We know that 2 lengths plus 2 widths equals the perimeter, which in this case is 30. So that's given me one equation. They also have told me if the length is 3 centimeters less than the width. So let's just break this down. The length equals 3 less than, the than is sort of a switch word, so the 3 goes at the back and the width goes in the front. So the length is 3 centimeters less than the width. And now you notice this is set up. We could have our traditional red equation and our blue equation, just like we have had before. Let's try to figure out which one is going to be easier to solve for. If I look at the length here, we could divide by 2. Everything seems to be divisible by 2. Here, again, divide by 2. Everything's divisible by 2, so it's easy to solve for both of these, L or W in the red equation. In the blue equation, L, you notice, is already by itself, so that's as easy as it gets. W, it wouldn't be much harder, but since L is already by itself, let's solve for L. So I'm just going to jot a note to myself. that I want to solve for L. Okay, so red, we're going to solve for L. We're going to subtract 2w from both sides. 2L equals negative 2w plus 30. Divide by 2. So L is by itself. Also in the blue, L happens to be by itself already, which is very handy. So now let's combine these. Negative 1w plus 15 on one side, w minus 3 on the other side, and now we go to the song. First distribute, nope. Then combine all of your like terms, nope. Please remember key change, or you'll get burned. Well, we can do that. It's completely optional though. Then get all your variables onto the same side, so we're going to subtract w from both sides. Negative 1w plus negative 1w is negative 2w. Then get all your variables onto the same side. First addition or subtraction. Then multiply, divide. Aha, so w is 9. Now, I want to plug that back in. It looks like it's going to be easier, a little bit easier with the blue. So let's try it with the blue. L equals 9 minus 3. L is then 6. Now, this is what we've been doing in the other examples, but we haven't applied it into a word problem context. Let's see what we've gotten done. Let, we've done that. That's good. Write, we've written the two equations, so that's good. Solve, we solved down to get the length and the width, so we've solved correctly. Check it. Well, let's make sure that this makes sense. Two lengths, so 2 times 6 plus 2 widths, which is 9, is supposed to equal 30. So that's 12 plus 18. Well, there you go. 30 equals 30. That's good. But the length, which is 9, let's give me 6, is supposed to be the same thing as the width minus 3. Well, 6 equals 6. That checks out as well. So both of these checked out correctly. Now let's just write a sentence. Find the area of the rectangle. We found the length and the width, but they don't want the length and the width. They want the area. Now, if you remember, in a rectangle, the area is going to be the length times the width. So 6 times 9 is going to be 54, and that's square centimeters. So we're going to say the area is 54 square centimeters. Okay, and one more. And this is a classic type of a problem, so you may want to keep an eye on this one. The office supply company sells two types of fax machines, 150 for one and 225 for the other. If the company sold 22 fax machines for a total of 3,900 last month, how many of each type were sold? Well, there's something you need to know about these types of word problems, and that is that one of the two equations is going to deal with the quantity, that is, how many. The other one's going to deal with the quality. or you could talk about the value. So we talk about the quantity and the quality, or how many, and the value. We're going to get two different equations. Now it says it sells two types of fax machines. We do need to just go ahead and do a let statement here. They charge 150 for one and 225 for the other. Let's say let X equal the $150 machines. Also let Y equal the $225 machines. That way we can keep track of which one is which. Okay, so they charge 150 for one, 225 for the other. Now, that's talking about the value of each. So, value, we're doing with quality, the 150 for the X machines is going to be how much it's valued, plus 225 of the Y machines. And it seems to be that the total value is $3,900. Yeah, $3,900. That's the value. Now, it also tells us that they sold 22 of these machines. So X, however many of those were, plus Y, however many of those were, equals 22. So this information is hidden within this. It's going to be very important that you know how to extract this information from the word problem. Okay, so we've done our let statement. We did our right, written two equations. Now we need to solve it. Now, I don't think it really matters which one I solve for, X or Y, so I'm just going to say let's solve for X. Just as a note to myself. Now I'm going to make this one the red, this one the blue, and let's get started. Solving for X, we have X plus Y equals 22. Solving for X, I need to subtract Y from both sides. X equals the opposite of Y plus 22. X is by itself. Now let's try the blue. 150X plus 225Y equals 3,900. We're going to solve for X, so let's subtract 225Y from both sides. So 150X equals negative 225Y plus 3,900. Just bringing this up, and let's divide by 150. Okay, so X is by itself here as well. A little bit more involved, but we've gotten through it. Now, let's join the two together and solve. X equals this. This goes on one side. X equals this. This goes on the other side. You notice that I left these fractions alone. That's because I'm going to go back through and multiply everything by 150 to get rid of these fractions. 150 times negative 1 is going to be negative 150. 22 times 150 and add a 0. All right, 3,300. Okay, so first distribute. Nope. Then combine all of your like terms. Well, we can't do that because we don't have all the variables on the same side. Um, then get all your variables onto the same side, so we're going to add the opposite. First, excuse me, then get all your variables onto the same side, first addition or subtraction. Then multiply, divide. Let's see. So y equals 4. Okay, since y equals 4, I tell you what, this red looks pretty easy, at least much easier than the blue is. So we're going to use the red to plug our value back in. So x equals the opposite of whatever y is, which is 4, plus 22. X equals negative 4 plus 22 is 18. So my ordered pair would be 18, 4. But we've got to think about this in context. Now, I will go ahead and say we have solved. We've gotten x and y. But as we check, let's go back through and do the red and the blue separately. X, which is 18, plus y, which is 4, is supposed to be 22. Well, that works out. That's good. Also, in the blue, 150 times x, which is 18, plus 225 times y, which is 4, is supposed to be 3,900. Now, 150 times 18, that's going to give me 3,300. I only know that because we had done that calculation a little bit earlier. Right here, 150 times 22. Ooh, never mind. 150 times 18. Well, I'm going to do 115 times 18 instead, and add a 0 later. So that's 2,700. Oops. Plus 225 times 4. And 27 plus 900 is going to be 3,600. So I've got to go back and look at my work and see exactly what I have done. Okay, figured out the problem. 600 divided by 75. Oops, that is 8, not 4. This is why it's so important to go back and check your work. All right, so if y is 8, then I've got to go back and look at the step where I plugged it back in. So this should be the opposite of 8 plus 22. That means 22 minus 8 can be 14. So now let's go back and check again. Let's try it in the red. 14 plus 8 equals 22. It's supposed to. 14 plus 8 is 22. And in blue, let's try that one more time. 150 times 14 plus 225 times 8 equals 3,900. We got 2,100 plus 1,800 equals 3,900, and that does work out. So it's a good thing that we went back and checked. So let, write, solve, check. Now we need to go back and put our sentence. Now they wanted to know how many of each type were sold. Well, it should be simple enough. There were 14 of the, let's see, that's the $150 machines. There were 14 $150 machines and 8 of the $225 machines sold. And there's my sentence. And I have all of it. Let, write, solve, check, sentence. All right, thank you so much, and have a great day.